Buenos dias and welcome back to Learning with the Fosters. Today we're going to go over the homework regarding our discussion on operations on sets or set operations, namely the complement of a set, the union and intersection of sets. So I hope you had a chance to work through them. I hope it went well, but I hope some were a little bit challenging, at least took a little bit of time. And let's go over them now together. So the homework, we have four different sets here. We have set A consisting of the elements 1, 2, 3, 4, and 5. Set B consisting of the elements 2, 4, 7, and 9. Set C consisting of the elements 6, 7, 8, 9, and 10. And D the set consisting of the elements 7, 4, and 11. And our homework was to look at some of the different relations and operations on these sets. The first task was to draw a Venn diagram relating to these, and then we'll work through the individual operations from there. So first of all, before we do that, let's note, as our Venn diagram, we'll draw it over in this corner here, or this area, not necessarily a corner. This is our universal set. And so before we put in our numbers here, again, the universal set is what? Yes, the set of all the elements under discussion in a particular conversation or a particular discussion. In this case, all the elements in A, B, C, and D. So all of these elements, in this case all numbers, will have to be placed somewhere in here. So before we move on, let's list explicitly the universal set. So help us, I hope you did this, it'll kind of help you go through as we work through these. So the universal set consists of the elements 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. The elements in B, 2, 4, 7, 9. We already have 2 and 4, so we have to add 7 and 9. Elements in C, 6, 7, 8, 9, and 10. We don't have 6. We can add that. Do we have 7? Yes. 8, 9 we already have, and 10. And the elements in D, 7, 4, 11. We have 7, we have 4, 11 is the only element unique to D. So there is an explicit description of the universal set. So now our task becomes to construct this. This is a little bit more involved than some of the sets we've looked at before. So I hope you had fun with this. When I look at this, the first thing I notice, or maybe not the first thing, but something of interest, is that sets A and C don't share any elements. And it's easy to spot because it consists of 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10. I did that intentionally to help us kind of see the relation that these sets don't share any common elements. So first of all, it'll help our picture if we know that there's a set A and a set C that are not going to overlap in any way. All right, again, you can see there's no space available for any of these elements to be in both A and C. Next thing, notice that D shares 2 elements with A and 2 elements with C. So based on our picture so far, that's fairly easy to add. We can add C and also there's no elements unique to B that are not contained in A or C. So we don't need much unique space here. We can simply construct B to look something like that. There's spots for 2 and 4, 7 and 9. All right. Now D shares an element with both B, 2 elements with B, 7 and 4, and 1 element with A, 4. And it's got 1 unique element, 11. So maybe that'll help. Let's just put 11 down here. He's outside of everybody. And we noticed that as we constructed the universal set, that 11 was the only element still left in D that we hadn't already talked about. So if we were to do this, 11 being the only unique element to D, 7 and 4 both being in B, and 4 being in A, we could construct another circle like that and label that set D. All right, let's put in the elements in A again, let's do the shared elements. In B we have 2 and 4 that are in A and B. So where's our space for A and B? Right here. We have 2, and before we put 4 in, we also notice that 4 is shared in D. So is there a space that allows for D, A, and B? Yes. Right there. All right, so we've got, I'll just underline 2, 4, taken care of. What about the elements, the other elements in B, 7 and 9? Well, they are shared with C. So where's the spot for B and C? Okay, so we have 9, the element 9 as being part of an element of B and also C. The element 7 being a part of set B, C, and D. So this spot here, similarly to what 4 was, is an element common to C, D, and B, and 4 was an element common to A, B, and D. We can see that there. Okay, we got the hard part done, all the overlapping stuff. Let's finish up with set A. What elements have we not talked about? 1, 3, and 5. Those are all elements unique to A. 1, 3, 5. And for C, we have elements 6, 8, and 10, it looks like, that are unique to C. Let's take a moment, make sure we did this correct. All right, now that we've oriented ourselves, we've constructed a Venn diagram, we can take a look at this, notice the relations. Now let's tackle the actual problems. Problem number 1. The intersection of the sets B and C. We want to find the intersection of sets B and C. Or in other words, what elements are common to both B and C? Remember, the intersection are all the elements that are common to both sets B and C. So let's first look at our picture. To me, pictures kind of help. So what elements, or what space, based on our diagram, are the elements that are in B and C? And this will help check to make sure our diagram's correct. So here's B, and here's C. So what elements overlap in B and C? Well, this would be the overlapping region, 9 and 7. So let's put in 9 and 7 tentatively, and let's check based on our sets up here. So we're saying 9 and 7 should be the only elements that are common to both sets B and C. B has a 2, does C? No. 4? No. 7? Yes. 9? Yes. All right. Very good, we match. So the answer to problem number 1, the intersection of sets B and C is the sets consisting of the elements 9 and 7. Let's look at problem number 2. The union of set D and A. Now remember, the union were the elements that are elements in either D or in set A in this case. So let's look at our diagram, or our Venn diagram. Set D consists of all these elements. So all the elements in D will be in this set. So our elements within D, this circle, 11, 7, and 4. Or this set will consist of all the elements in A. So where's A? Right here. We notice that there's one element that's shared between A and D, so we don't want to be redundant. We already have the 4, but we'll include all the other elements that are in A as well. 5, 3, 1, and 2. All right, let's see how it looks up here. So we should have all the elements in D, 7, 4, 11, 7, 4, 11, or all the elements in A, 1, 2, 3, 4 we already had from set D, and 5. All right, let's move on. Problem number 3, dealing with the complement. Remember, the complement consists of all the elements within the universal set, also not the elements in this case, set C. So let's look at our diagram. Set C, this circle here. So we're not going to include these elements. Whatever else our set may contain, it does not contain 7, 9, 6, 8, and 10 because that is set C. What it does contain, or to state it positively, it's all the sets within the universal set, so everything under discussion, with the exception of C. So we should have 11 is in the universal set, but it is not in C. 4, 2, 1, 3, and 5 are all in the universal set, but they are not in C. So 11, 4, 2, 5, 3, and 1. All right, let's take a look up here. So we should have all the elements within the universal set. That's why it's helpful to explicitly list it, at least in this case, but not including the elements in C. So the elements in C are 6. We don't want 6. We don't want 7, 8, 9, and 10. So the elements without a white underline are the ones that should comprise this set. 1, 2, 3, 4, 5, and 11. All right, the complement of C. Problem number 4. The intersection of A and C. All right, so that is the set of elements that are common to both A and C. Well, let's look at our picture. Here's set A. Here's set C. Ooh, there's no overlap, is there? So there are no elements that are shared in both A and C. Remember the term for that? Very good, a disjoint set. So how do we denote that? Well, what we've been doing is simply putting the elements in. There are no elements to be shared, so we have our empty set. And we could also write that with our other notation we've been using. So the intersection of sets A and C is the empty set. There are no elements in common. Let's double check though, because that's a little odd, at least it appears. Let's check up here. In fact, that's one thing we noticed right off the bat. We're looking for the elements common to both A and C. Well, 1, 2, 3, 4, and 5, 6, 7, 8, 9, and 10, there are no elements that are contained in both sets. So we were correct. It is the empty set. All right, let's look at problem number 5. All right, we're getting a little bit more involved here. I'm going to first look at the intersection of D and B. And whatever that turns out to be, we want to find the union of that with set A. Okay, so remember a brief discussion or a review on a few aspects of order of operations. We're first going to tackle the intersection of D and A, and whatever set that turns out to be, we'll take that with the union of A, and that will give us our final set that we're looking for that describes this situation. So first, let's do the parentheses. We'll do our work here in yellow. Let's find the intersection of sets D and B. Again, the elements common to D and B. So here's D, here's B. The elements shared between them, the common ones, are elements 4 and 7. So underneath here, I like to keep things kind of organized. We'll say this is, rather than writing it as the intersection of D and B, we'll write it, it's equal to, it's an equality. We'll write it as the set consisting of the elements, what did we say, 4 and 7. So we'll bring our work from up here down. Now let's check this answer up here. We're saying 4 and 7 are the elements that are common to both D and B. D and B, 7, yes, 4, yes, 11, no. 2 and 9, no. So 7 and 4. Looks like we're doing good. So now we want to take this and find the union between the set consisting of the elements 4 and 7, or in other words, the intersection of sets D and B with the set A. So our answer will consist of all the elements that are common to set 1, in this case 4 and 7, or in addition to our elements that are elements of set A. So set A consists of the elements 5, 2, 1, 3, 5. We already have a 4, so we'll add 2, 3, 5, and 1. Let's confer up here. We have 4 and 7. In addition to set A, we have 1, 2, 3, 4, we already had, and 5. All right, so this is the answer. Or in other words, this is the set that describes this situation or this expression up here. We're taking the union of the intersection of sets D and B with set A. So let's look on here and note where this would be. So we have set A, if we were to shade this, all of set A in addition to the element 7. So this whole shaded area here is what this situation is describing. All right, that was a little bit more interesting, I think. 6, we have the complement of C. Now remember, this is read C prime. All right, so we don't have parentheses, but we really have 2 different operations going on, just like we had in the previous one. We first have to find the complement, working left to right, of C, and then take the union of that with the set B. So the union of the complement of C and B. So first, let's deal with this C prime, or the complement of C. Remember, that is everything in the universal set that is not in C. So we want everything in the universal set. Up here we have in orange, but not the elements that are in C. So let's underline those, and we'll take what's left. So we don't want 6. We don't want 7. We don't want 8. We don't want 9. And we don't want 10. So what we're left with, so the complement of C, the elements 1, 2, 3, 4, 5, and 11. Now, I was nice on this because we had already found the complement of C in problem number 3. So if you kept track of your work and remembered what you were cognizant of what you were doing, you wouldn't have had to redo this. We already found the complement of C. But just for practice, we redid it. And let's check to make sure it's the same. We have 1, 2, 3, 4, 5, and 11. So our C prime, double checked, is still this set here. We're going to bring down, we're going to take that set, the union with set B. So remember, the union consists of all the elements in set 1 in addition to, or the elements in set B. So we'll write the complement of C, the set we already explicitly listed, 1, 2, 3, 4, 5, 11. And now we're also going to add any elements that are not redundant from set B. So set B consists of 2, 4, 7, 9. Is there a 2? Yes. Is there a 4? Yes. Is there a 7? No. We'll add 7. And a 9? No. So our set, or in other words, the set that is the complement of C with the union of B, consists of the elements 1, 2, 3, 4, 5, 11, 7, and 9. A little bit interesting one. All right, so far so good. Let's see what problem number 7 has for us. We have the union of sets D and the set that is the intersection of B prime, or the complement of B, and set A. So we really have an extra amount, a little additional step we have to do first. Remember, we work from right to left, but we start with the parentheses. So we're going to start with what is in this area. But before we just look at B and A, what do we have to do first? Yeah, we have to deal with the complement. We have to find this operation, namely what is B prime. So let's do that first of all. So remember, B prime is everything in the universal set that is not in B. Let's start with our picture this time. So our universal set is all these elements, but we don't want the ones in B. So here's B. We don't want 2, 4, 7, or 9. So we have 1, 3, and 5. 11, 10, 8, and 6. All right, this is the complement of B. Let's check up here. Here's our universal set. We want all elements with the exception of the elements that are elements in B. So we don't want 2, we don't want 4, we don't want 7, and we don't want 9. So our set should consist of 1, 3, 5, 6, 8, 10, and 11. All right, we're looking good so far. So let's bring the rest of our work down. Okay. So we found out what B prime is. So now what do? Yeah, we take what's in the parentheses. We're going to take the intersection of sets A and our explicitly listed B prime. So remember, those are the elements in common. So for the sake of not being redundant and writing things over and over, let's look at our listed set here and what elements within this are common to, or are also elements within set A. Here's set A. Let's use our listed values up here for this one. So we'll underline, or we'll circle the elements that are common. So there's a 1 in A. Is there a 1 here? Yes. There's a 2 in A. No 2. 3. 4. No 5. All right, and let's just continue down and checking here. Is there an 11 in A? No. A 10 in A? No. An 8? No. And a 6? No. So elements 1, 3, and 5 are the elements that are common, or the intersection of B prime and A, where all the elements not in B and in A. So this becomes a set 1, 3, 5. Now, let's check with our picture. It's getting a little bit complicated, but let's just see if we can follow what's going on. So what we're saying, we're just dealing with this parenthesis part, is we're looking for the elements common to set A and all the elements that are not in B. So within set A, that kind of limits our scope. It has to be these elements. And the elements that are not in B, well, the elements that are in B that are under the discussion here would be 2 and 4. So what we're left with are the elements 1, 3, and 5. And that's exactly what we have. So I think the picture really helps confirm some of the confusing going through this. It really helps us to see that we're on the right track. All right, but we're not done yet, are we? We have one more item to deal with. We are looking for the union of sets D and the set containing the elements 1, 3, and 5. Remember, the union in some ways is easier. It's just listing all the elements that are not commentable, that are in both, without being redundant. So we know that it will consist of all the elements that are in B, 11, 7, 4. In addition to any elements that we have not listed from set 2. 1 we don't have, 3 we don't have, and 5. All right, so essentially what this whole initial expression describes is the set consisting of the elements 11, 7, 4, 1, 3, and 5. So for our picture, the area it's describing is this area here, 1, 3, and 5, and also 11, 7, 4, which is set D. So kind of this crescent-shaped moon in addition to this area is what this particular situation was describing. I think that one was kind of fun. Let's see what the next one is. It's getting cloudy. You can see the rain coming over there from the somewhat east. There's expected to be a lot of rain and a lot of wind the next week or so here. Let's see if we can wrap this up before it pours on. Okay, we're looking at the intersection of sets B and the set that is the intersection of sets A and C. Now remember, we do parentheses first. So let's first deal with the intersection of sets A and C, or all the elements common to A and C. Here's A, here's C. Oh, we already looked at that, didn't we? And we kept it up on the board intentionally. There are no elements common to both. So the intersection of A and C is the empty set. All right, let's bring the rest of our work down. Interesting. We're looking for the intersection of set B and the empty set. The intersection, again, recall, are the elements that are common to both. Well, the empty set, maybe we'll rewrite it as using this notation. There are no elements within the empty set, therefore there will be no elements common to both B and the empty set. So the answer is the empty set. Now let's look at our picture. We're looking for the intersection of A and C. We noted there are no elements in common. Any elements in common with that with B? Nothing. All right, problem number 9. We're having fun with the empty set. We're looking at the complement of the empty set. Make sure you can see the prime marking there. So we're looking at the complement of the empty set. We want to find that. Well, okay, so the complement is all the elements of the universal set. And remember how we've been doing this. One way we've been doing this is kind of going through and crossing out the elements that are in the set that it's the complement of, and we take everything else. So let's kind of do that. Everything in the universal set. Okay, now it's time to cross out the elements that are elements of our set under discussion. In this case, the empty set. There are no elements, are there? So there's nothing to cross out. So the complement of the empty set is the universal set. We could list these explicitly, or to save time and hand strength, the universal set. Now let's look at our picture. So all the elements in the universal set that are not in the empty set. The empty set has no elements. Everything that is left, we haven't taken anything out, still the universal set. So the complement of the empty set is the universal set. All right, one more. Problem number 10. All right, we've got a number of things we have to work through, but I think at this point we should be pretty capable of doing so. So we're starting left to right, but dealing with parentheses first. Everything within here, we have to first deal with this complement. So let's figure out what B prime is. All the elements in the universal set not in B. So all of the universal with the exception of 2, 4, 7, and 9, or up here with the exception of B. So we have the elements 1, 3, 5, 11, 6, 8, and 10. All right. Kind of intruding into our picture. Let's bring the rest of our work down. All right, still working within the parentheses. Let's take the intersection of set D and the set we established here, the prime or the complement of B. So what is in common with D and this set? Well, we have a 7. Do we have a 7? No. Do we have a 4? No. Do we have an 11? Yes. So this whole mess equates to simply the set containing the elements set 11. Element is common to the complement of B and D. And again, I'll leave that to you at this point to kind of look at the picture and see what's going on. All right, let's bring the rest of our work down. A prime. We're taking the union of the complement of A and the set containing the element 11. What do we have to do first? Correct, we have to deal with the complement of A, so let's find out what that is. So the complement of A is everything in the universal set with the exception of the elements in A. So 1, 2, 3, 4, and 5, everything this direction. So we have 7, 9, 6, 8, 10, and 11. That is the complement of A, or in other words, everything in our universal set that is not in A. 11, 7, 9, 6, 8, 10. All right, let's bring the rest of our work down. Okay, so we've got, I guess I need my set braces, don't I? So now we are looking at the union of the sets 7, 9, 6, 8, 10, 11, and the set containing the element 11. So everything that is within set 1, 7, 9, 6, 8, 10, and 11. Also everything in set 2 that's not redundant. We already have an 11. So here is our answer, which turns out to be the complement of A. Not too bad. I hope you enjoyed that. All right, great job, great work. And again, we're in the pre-calculus course, so this is about as far as we're going to go into set theory. And believe me, this is the very, very tip of the iceberg. It gets quite interesting, but this will allow us some tools and precision to talk about, well, quite a number of things. As I mentioned, it's very fundamental to math. But in our next lesson together, we will begin to look at number systems, and some of the different nuances of those that will be applicable to what we will be doing in this course. And our discussion on sets will really help out with that, I think. So join us next time as we'll begin looking at the real numbers and some of the subsets within that. Look forward to seeing you then. Have a great day.
Thank you for learning with the Fosters. This is a friendly reminder. Remember that these courses are not for free. For information of the cost of the lessons and how to pay, please visit our website. Thank you so much for being with us.